Hello, students. I'm going to go very quickly through the notes that we did in class today. And you can use this to help you fill in anything that you didn't get done today when we were talking about this. So on your notes sheet, you already have these little football goal looking things in. So this is the basic outline of our cladogram. And so you're going to use those and you're going to fill in quite a bit of stuff around those. The first thing that I would like you to fill in is that I would like you to write in, whoops, that's a little bit bigger than I wanted. I would like you to fill in this information here, taxon A and taxon B and taxon C. So I'd like you to write those in. A taxon, we say right here, is an in group. Basically, a taxon is just a group. It's a grouping of organisms. Usually it would be a species, but that might not always be true. So we can just talk about this kind of generally and say it's a group of organisms. If you're talking about more than one taxon, the plural is taxa, T-A-X-A, taxa. So you're going to write in taxon A, taxon B, and taxon C. Now, we're going to start talking about putting these things into smaller groups. So we're going to talk about something called a clade. And I'm not going to give you a whole lot of really good definitions about a clade today. Instead of giving you a definition, we're going to just work with that clade so that you understand the overall concept. Later on, we may put in an actual definition, but I want you to see like how it functions before we try to learn, just a quick sentence about it. So in order to build a clade, we're going to take in what's called a node, and we're going to take in all of the taxa after that node. So if you want to, let me go in here. If you want to, you can go ahead and put your nodes in. So you can put one in right there, and you can put another node in right there. And so you've got, I've got these drawn in purple. I think that's purple ink anyway. And so I've gone over them in purple marker here. But let's go ahead and let's put taxon A and taxon B in a box because both of them share that node right there. So I'm going to draw all the way around this. And I'm not doing a very good job because I'm working with my old mouse. There we go. So now we've got this whole group drawn in. Okay. So that means that these two groups are kind of the in groups. We call them sister groups, or we call these sister taxa. So this is the sister group. Taxon A and taxon B make up the sister group. Taxon C over here, if we're talking about the orange box, it's not being invited to the Super Bowl party, okay? It didn't get invited to come over. It's left out. And we call it an out group. So it is, taxon C is the out group to A and B. It doesn't share this ancestor, and therefore it's not part of the orange club here. Now, let's say that we want to get a little bit broader in our grouping. So if we want to get a little bit broader in our grouping, I'm going to use green here. And again, I'm not going to do a very good job of drawing here because I'm using the old mouse with my Chromebook. But there we go. You get the idea. There is some kind of a box that I've drawn in here. Now, taxon C is much happier because now taxon C is in the group. So it's now in this whole sister group. And taxon C gets to go to this much bigger Super Bowl party. All right. So that's kind of the basic idea. And we can define what these groups look like. So just like if you have, I don't know, Thanksgiving dinner or something at your house, then it might just be like your parents and you and brothers and sisters, if they have kids, sibling or spouses, whatever, then they may all come together here. Or you might go to a Thanksgiving where it's like your grandparents and everybody that descends from them. So you're going to be able to define what these clades or what these groups are. Let's talk about a few more things in here, though. So if we're looking at A and B, and I'm going to put in a little box here. The orange is really what shows that A is more closely related to B than to C. So A and B are in the orange clade. That means that's pretty close to where they are. Like, you could just box in A by itself, but that would be the only way that you could get a smaller group than a group that includes taxon A and taxon B. So that tells you that taxon A is more closely related to B than it is to C. Taxon B is more closely related to A than it is to C. Okay? And that's because these two share a more recent node or a closer node. This line up here would be kind of now. The farther back you go would be older. Okay, so I'm going to erase a little bit of this because it's pretty bad. And you can see the drawing on the paper. Now, what do these nodes mean? So a node shows a common ancestor usually with a particular trait, but it shows a common ancestor. So nodes show common ancestors, and then the taxa that are after that node are descendants from that ancestor. So if you're looking at this node right here, taxon A and taxon B are descendants of this ancestor. If you look at this one over here, though, taxon A, taxon B, and taxon C are descendants of this ancestor. So you can go back and see where the different taxa share the most recent common ancestor. You could probably change this or add to it to say that it is an ancient or a prior common ancestor. Just the ancestor should get it, but if you need a little bit of extra wording, you could put that in there. Okay. So what are we going to do with this? Well, we're going to move down here a little bit farther in our notes. And we're going to look at what the application of a cladogram is. And mostly that is to look at comparative anatomy. So looking at comparative anatomy brings in what we've learned about fossils, and it brings in what we've learned specifically about comparative anatomy in the discussions we've had in class. So you might look at some fossils within rock layers and figure out how old they are, and then bring those fossils in and compare the anatomy of the different fossils, kind of like what we were doing with some of the whale activities and what we'll do later on with the whale activities, so that we can try to figure out, okay, so what are the relationships? How did things change? What traits do they have in common? What traits do they not have in common? What traits did they lose? What traits over time did these different organisms gain? So cladograms help us to just organize that information. Now, we're going to talk a little bit about two specific words. And if you did all of your homework from last week, when we had talked about the comparative anatomy we had drawn like circles around the different bones, and then we talked about like what are the jobs of the forelimb for the human, the forelimb for the bat, forelimb for the crocodile, and so on like that. If you got to the end of that section, and right after the fish, if you went ahead and read about homologous and analogous structures, you already are a little bit familiar with these terms. If not, then you might want to go back and finish that part of your work. But we've got some terms here. So we've got homologous, and that's the one we're going to talk about first. So with homologous structures, there's a common ancestor, and here's the big important part, with the trait. So if you think back to that first part of that activity that we did, we looked at the birds and we looked at the bats, and we had looked at how their wings were made, and what was it that we said that birds and bats both use their front limb for? Exactly. Both of them use their front limbs to fly. So if you look at birds and bats, we know that they both have a front limb and they both have back limbs as well. So they have four limbs. They are four-limbed organisms, and we call those tetrapods, tetra being four, and the pods having to do with the limbs. And so we know that the ancestor came from a pretty long time ago. And so they branched off after this ancestor. That means that there's some other characteristic up through here that distinguished them. Okay? But they both share this characteristic. So the front limb of the bird and the front limb of the bat would be homologous structures because they both have an ancestor with four limbs. Now, analogous is the other word. And so in analogous, there is no common ancestor with the trait. And again, in both of these situations, the key word is, or the key phrase is with the trait. If we just say there is a common ancestor or there's no common ancestor, that doesn't completely answer the question. So homologous is there's a common ancestor with the trait. For analogous, there's no common ancestor with the trait. Okay, so let's look at that. Still looking at birds and bats. And if you think back to what the bird wing and the bat wing looked like, the bat wing looked like it had really long fingers. So it had really long metacarpals. The bird wing had fused metacarpals. So those two organisms had wings that were very, very different. They still have the same basic morphology or the same basic shape, but those bones have done different things. So back here would have been, somewhere back in here would have been the common ancestor with four limbs, but the wings developed separately. They didn't have, at their last common ancestor, this common ancestor did not have wings. And we know that because the bird wing developed looking very different from the bat wing. So that helps us to understand if those wings don't look the same, then that helps us to understand that they didn't come from a common ancestor with that particular trait. Now, the limb itself came from a common ancestor, but the wings developed separately. And so we call those analogous structures. They are structures that do the same function. They allow these organisms to fly, but they developed independently of each other. And you can tell that because they have very different structures within them. All right. And what we talked about in our worksheet was bird wings and butterfly wings, which are very, very different. I wanted to use the bird wing and the bat wing because I wanted to show you how there's a real key to this. And the key is that when you're talking about homologous and analogous structures, we're really talking about user-defined traits. Traits are good too. We're talking about user-defined traits. The key is in the trait that you are talking about. And we see that here. So just looking at four limbs, that's a homologous trait. There is an ancestor that they both share. So a common ancestor with the trait of four limbs. But if we're looking at the wings, and specifically looking at a bird wing and specifically looking at a bat wing, then what we see there is that those are analogous traits. Their common ancestor had four limbs, but they do not have a common ancestor that had wings. So there we go. And there's a little bit more here that you can look at. So this one, the note is that we're just talking about having four limbs and looking at front limb similarities. Over here, we're talking about specifically about wings, not just do they have four limbs. All right. So this is your notes for class, and go ahead and finish these up on your worksheet. And I hope that this is helpful to you in going back through and understanding.